This screencast is brought to you by the ChemSims project. This project is supported by a National Science Foundation grant. The screencast is designed to help you understand how absorbing energy can impact the electrons in atoms and what that has to do with the colors that elemental gases give off. In this simulation, we will be using the PhET simulation for neon lights and other gas discharge lamps. And although we are looking at an example of a discharge lamp, the same principle applies to fluorescent lights and is closely related to how LED lights work as well. You can find the simulation that we are using here at the PhET website, and there will be a link in the video notes below. This screencast is designed to work with an accompanying assignment that has you answer some questions as you watch the screencast. You'll be encouraged to pause the screencast periodically to reflect on what you have seen and answer the questions. The questions can be found at the ChemSims website. As you can see, we have a battery here that has a variable voltage we can apply across these two plates. Electrons will move from the negative to the positive plate when we click on the fire electron button. The amount of the energy that the electron has will depend on the voltage of the battery. Let's get the electrons going here. If we look over at the right at the energy level diagram, we can see that the amount of energy that the electron in hydrogen could have if it absorbed all the energy from the passing electron. In this case, we see nothing happen. This is because the electron can only occupy specific energy levels based on the different orbitals in hydrogen. However, if we increase the voltage and thus the energy, then we can see that it's possible for the electron to absorb enough energy to excite it up to the second energy level. Let's add in the squiggles so that we can see when the electron drops down in energy. When that happens, we also see a photon of light get emitted from the atom. This is represented by the colored fuzzy dot moving away from the atom in a random direction. Let's max out the voltage so that we can be sure to excite the electrons to any of the energy levels. Let's also add in the spectrometer. This will tally the photons that are coming off the atom. You are encouraged to pause the video and answer the first set of questions. We now have the simulation running in slow motion mode. This gives us a better chance to see exactly what happens as the electron encounters the atom. The electron from the plate comes and encounters the atom and excites the electrons of the atom up by giving up its energy. You can see it moves slower. But let's see what happens as it relaxes down. You are encouraged to pause the video and answer the next set of questions. Now let's look at a different atom, sodium. We can see that its orbitals are at different energies than those for the hydrogen atom. It would be good to pause the video for a few moments and answer the third set of questions. To make this easier, we'll provide the diagram for hydrogen here to look at. Also be sure to make a prediction for what you think will happen if we adjust the voltage back to 15 volts for sodium. Let's test your prediction. Again, we can let this run on continuous to see the emission spectrum of sodium. Let's look at some images of different gas discharge lamps. Here we can see that the different elemental discharge lamps have different visible colors. Answer the final set of questions that includes explaining why the simulation can help us understand that different gases would each appear as a different unique color. In fact, you can even use the color of a neon light to determine if it does indeed actually have neon in it. You should now be able to answer the final set of questions. Thank you for watching this ChemSims webcast.